Hello and welcome to the first lesson for Miss Miller's geometry class. Today we're going to talk about Cornell Notes and basic geometry. Today what you want to do is focus on watching the video, write notes using the Cornell Method, compare your notes to the examples at the end of each section, and then be sure that all of your notes have the important points of the lesson. Then go ahead and reread your notes so that you're prepared for the class activity we'll be doing next class period. The learning targets and objectives for this lesson are that you will be able to create a study guide using the Cornell Method, identify, name, and draw points, lines, segments, and rays and planes, and that you will be able to apply basic facts about points, lines, and planes to problems using postulates. First of all, we need to learn how to use the Cornell Method. The Cornell Method is a method of taking notes that allows you to create your own study guide, organize your lesson notes, and be a more successful student. First, you have to set up your paper. I would set up several pages at once so that you have plenty of paper to use for all of your notes for your classes. You're going to draw 2 horizontal lines as are shown here, one close to the top of the page and one 5 or 6 lines from the bottom. Make them dark. I would use a magic marker. And then one vertical line so that you have an area in the center here, a small area to the side, and a large area down below. You're going to write your course name and the date and the topic. This one would be Cornell Notes. You put this on the top of each page so that you can easily look through your notebook and find the notes on the subject you need help studying. The large box is for the actual notes. You should keep them simple. Learn to abbreviate when possible. Skip a line between the main ideas so that it's easier to use later. After you've written your notes, you review them that evening after class, or in this case, after the video. You'll go ahead and pull out the main ideas, those key points. You'll put them here in this small column to the left. These would be, in our case, vocabulary, formulas, or main ideas that you need to remember. At the bottom, you're going to put a summary of the lesson, just so that you know what it's about, the main part of your notes. You don't need to write every word there. Your summary should include the main idea. It shouldn't have all of the vocabulary because those are the key points over here. So your main idea goes at the bottom, just what you would study for a test. To use your Cornell Notes, you'll reread them in the right column, but spend most of your time studying the ideas in the left column and the summary. Those are the most important ideas from all of your notes that will include the information for the assessments. Do your notes about Cornell Notes look anything like this? Take a moment and fill in anything that you might have missed. And then we'll go on to our first lesson about geometry. The vocabulary you should know would be undefined term, point, line, plane, collinear, coplanar, segment, endpoint, ray, opposite rays, and postulate. The building blocks of geometry are found in the very three terms that we're learning here. They are undefined. Undefined terms are terms that cannot be defined using other figures. You must use your imagination to see them. For example, a point. If you look at the computer screen or at the table your computer sits on, you can pick out one small location there. And you can imagine that it's a point. Kind of like a desktop. It has molecules in it. And those molecules, you don't really see them with your eye, but you can kind of just imagine where one of them might be in that whole desktop. A straight line is a path that extends forever in both directions. It has infinitely many points on it. You can think of a point at one corner of the screen and a point at the other corner of the screen, and imagine a line that goes through both of those points. It will be straight, and you could put infinitely many points between those two. Whereas a plane would be something like a piece of paper could be an example, or a wall. But in reality, a plane is a flat surface that has no thickness, that extends forever in four directions. These are the three building blocks of geometry. All of our other notions will be based on these three. So let's try drawing them. If I ask you to draw a point, that's pretty easy. You just put a dot on the page. We would label it with a letter or a number, but in some way to identify that particular location. We draw a line, a straight line with arrows on each end, to signify that it goes on forever in both directions. A plane we usually draw as some type of parallelogram. But we know that it would continue on, both across and up and down. It has no thickness, so it would be like a sheet of paper that never ended. When we think of lines and points, we have other definitions that are fairly obvious. 2 points that are on the same line would be collinear. You can think of a copilot. They're on the same plane. They're on the same airplane. Coplanar means they're on the same geometric plane. A part of a line that has a point at each end is a segment. Generally, we look at things that are segments. Since lines go on forever in both directions, most of the items we see are just pieces of lines. The points at each end, the stopping points, are endpoints. So imagine a line, except that you've cut it in half and you have an endpoint at one end, and then a line that extends forever in the other direction. This would be a ray. Opposite rays share the same endpoint, and because they go on forever in opposite directions, it's like gluing our line back together again. It does create a line. In math, we have a lot of important statements. We call them postulates, sometimes axioms or theorems. Postulates are formal statements that are accepted as true without proof. We have several about points, lines, and planes to help describe the properties in geometry. The first postulate we want to think about is 1, 1, 1, and it states that through any 2 points there is exactly one line. If you try to draw more than one line through the same 2 points, you'll fail. You can try an experiment. Postulate 1, 1, 2 says that through any 3 non-collinear points, there is exactly one plane containing them. Another way to think of it would be, if I have a line, I have 2 points on that line, and then I have another point that's not on the line. Through all of those, I could put them on a sheet of paper. They would be contained by one plane. Also, if 2 points lie in a plane, then the line containing those points lies in the same plane. Think about a brick wall. That would be our plane. All of the little intersections, the lines where the bricks meet, those would be a line in the wall. It's also a line in the plane. The last 2 postulates we need to know about in this chapter, with this section, are that if 2 lines intersect, then they intersect in exactly one point. The same 2 lines cannot intersect at a different point because they are straight. Likewise, if 2 planes intersect, then they will intersect in exactly one line. A good example would be to think about the intersection of your wall and ceiling. You could draw a straight line where they intersect each other. Now that we've gone over the very basics of geometry, our building blocks, do your notes look anything like this? Please make sure that you have your notes for class, as we will be using them in an activity. Have a good day.